Good evening and welcome to Kopernik Observatory. My name is Drew Desker. I'm the director of the observatory here. I want to welcome everybody here at Kopernik and also those watching on the live stream. A little tired today. We just finally finished our summer camps. We had 7 weeks of summer camp for students as young as entering second grade in the next couple of weeks up through high school. And we had a number of exciting camps. We did some stuff in VR. We had our students talk to an astronaut on the ISS using our ham radio station here. And this week we just finished a high altitude balloon camp where our students put a payload together, put it on a weather balloon that went up to almost 99,000 feet. And we tracked it with some radio beacons, and were able to actually retrieve the payload once it rapidly returned to Earth. And we'll leave it at that. Yeah, the parachute fell off of the payload, and so we learned about terminal velocity today. But we actually. I think I calculated it from when it was finally hit most of the atmosphere, and then like around 30,000 feet, and then hit the ground. I was estimating it's about 60 miles an hour when the payload finally hit the ground. It was a styrofoam container, but oddly enough, all of the electronics worked. The GoPro cameras were still recording. So we actually you can hear the kids coming up and then, picking like, oh my gosh, look at that. so we actually watched that video. So that was a lot of fun. I'm sorry? Yeah, so I'm actually thinking I'm going to have to reach out to GoPro and see if they might find that useful. But anyway. Yeah. Okay, so the question is, when we send something up in weather balloons, technically, because our payload was under 4 pounds, we don't really have to. However, it's still a good idea to do so. And it was actually part of the lesson plan was to have the students understand, here we have to contact the FAA. And so here in Binghamton, we contacted the Binghamton Tower. But then you learn that, okay, well, the Binghamton Tower is really only interested in what's between the ground and about 8,000 feet. If it's above 8,000 feet, I'll say they don't care, but that's when the New York City Center has to take over. And so we called down to New York City's air traffic controller and made them aware. We gave them the information on where it was headed. Again, we didn't have to, but it was a good exercise for the students. We actually had the students talk to the air traffic controllers to make them aware of that. So, again, it's a lot of fun. The images that came back, especially up at 98,000 feet, you can see the curvature of the Earth. You see the blue streak that is our atmosphere, and then everything above that is all black, and in space. So, anyway. We had a wonderful time this summer. Had 193 students over the summer come up here. So, but one of the things that I really enjoy is actually these Friday night programs. It's an opportunity for us to really promote lifelong learning, and not everything we talk about is about astronomy. And although today we're going to be talking about straw. Sorry. I probably should have left that one alone. But anyway, it's really an opportunity to step outside of what we sort of is our own little knowledge zone and learn something new. And maybe it's building on something you already know, or just finding how do things work, and or what's a new way, or in this case maybe it's even an old way of doing something that you sort of you get new eyes on. And so tonight we have just that kind of a talk. We're fortunate to have here in the area Laura Intscher, who is with Secrete-based design, and talking about specifically sort of a unique approach, or a unique. Well, it's maybe an approach that most people may not be aware of, but it's of how we can be more ecologically aware and of building homes that are well. Actually, I'm going to not step on your. I'm going to stop talking and turn it over to you, Laura.
Okay. Hello. So, I am Laura Intscher. I'm an architect, and my company is Secrete-based design. And this talk is about building with straw bales and clay plaster. I have been an architect for more than 30 years, and I've worked in all different kinds of sectors: commercial buildings, residential buildings, building with all different kinds of building materials and different types of buildings. And in the last 20 years or so, more than 20 years, I guess, I've started getting more and more into natural building and straw bale construction. It has become my specialty. I think I'm pretty much the only New York State architect that really focuses on straw bale construction. By the end of the talk, I want all of you to want to live in a straw bale building. If I've done that, that's wonderful. Conventional buildings of the last, say, 75 years or so have not been very environmentally sustainable. Making and using the materials required for our buildings take 40% of the material that we produce, and it's also 40% of the landfill currently, and that's every year, just from the building industry. Natural building is focused on making improvements to this, and straw bale is a component of the natural building field, and that's where I am focused to make change and make progress. Promise you there won't be very much numbers, but this is one of them, and this is what the problem is. The red part of this pie chart is all things related to the building industry and the houses, how we use them. 15% of global carbon emissions is from our structure, the actual buildings that we make. When we're using those buildings, the heating, cooling costs, and everything inside that, your lighting, your equipment, your refrigerator, when we use that, that's producing 27% of the global carbon emissions. When we add in interiors, that's another 13%. We talk a lot about energy efficiency in cars. Actually, transportation is only 20%, 22% of the global carbon emissions. When we add up all the things related to our buildings and how we use them, that's over 55%. Yet we're not talking about it as much as we really need to be, and there's so much room for improvement. And I couldn't find data on transportation of getting materials to the building site. So it's probably even a sector of that 22% involved in energy for our buildings. Strength, function, and beauty. This is a saying from a Roman architect, Vitruvius, that I take to heart. Everything must be in balance. And if we look at the benefits of natural building and straw bale building, what we're aiming for is benefits in two areas. Global benefits that benefit everybody in the community and our environment, and that includes using less fossil fuel, sequestering carbon, and reducing waste. If we're talking on the individual level, that's the person inhabiting the building, we can save you money through energy savings. Heating and cooling costs will be less. We're making a safer building for you, something with less toxic materials, something that's fire resistant and more protective. And it's also long lasting, so you're not going to have to replace it as much. So there's many benefits on both the global and individual level why we want to be changing how we build. I want to have you keep in mind why don't we see more straw bale buildings, just as we're going along? We're going to talk about what it is and what are the benefits as compared with conventional construction. But keep that question in mind. Why aren't there more of these? Why don't we see them? Why isn't it something that we see every day? All right, let's talk about what it is. It is literally what it sounds like. It's buildings made of straw bales. And natural plasters. I know you guys are used to talking about rocket science here, but this ain't it. This is very, very, very simple stuff. Straw bales and natural plasters. The walls are literally built with straw bales. And let's talk a little bit about what that is. Straw bales are a waste product from agricultural production. We have them. We can use bales from wheat, rye, barley, rice, and they're just there. If we put them into our buildings, we're taking something out of the waste stream and using it. The bales are approximately 14 by 18 by 36 in size, and they weigh about 40 pounds when they're dry, which is how we want them. When we're looking for a construction bale, it doesn't have to be anything fancy. Your farmer down the street can make bales for you. All you're looking for is something that's pretty compactly packed, that's uniform in size. It makes it a lot easier to stack them if they're that way. And we want them two twine tied, either with wire or with poly. If you can pick them up with one string, holds together, it's good enough for bale building. Nothing special required. We usually like to use fresh cut straw, which is usually available at the end of July or the beginning of August. But if your construction schedule doesn't allow for that, you can store them in a cool, dry place over the season until you're ready to use them. We're looking for about 15% humidity, which can be measured with a humidity meter. And they are, as you see here, stacked, typically in something called running bond, which is where the joints don't align. Just like Legos, just like building with Legos. But they can be put in any orientation, and that depends on the type of construction that you're doing with them. Once you have them stacked, they get pinned together, and you want to keep them above ground so you're not getting any water wicking into your wall. So those are the basics about straw bales. They form the wall surface and the insulation. I really like building this way because it is so simple. Bale wall, protective plaster. That's it. Here are some bale tools. We have some unique equipment that everyone loves. On the left-hand side, you'll see everybody's favorite, which is called the persuader, which I have one here, a comically large Thor-sized hammer, used to gently persuade bales into the desired location, gently. Another unique tool that we use is something called the bale needle, which is right here. And it's basically a needle that you put through the bales. It has openings here for twine. And you can restitch the bales and tie them differently. And we just made this with a piece of bar stock. So not very expensive tools are needed to do this. You do need some twine for making your retying, and don't try to save money. Use the thickest twine you can, otherwise you will be very sad. We do use power tools to cut and shape the bales. You can use normal hand saws. It does take a little bit longer. If you're working with bales, you do get a lot of loose straw about. So it's better not to use anything that's not electric powered. You can shape, this is in one of our projects we were shaping the bales and creating notches for when it fits into the structural system. And here we're just using that with a chainsaw. You can also use regular saws, circular saws, and then to chop and shape bales even more, you can use a string trimmer. You can make curves with your string trimmer that you usually trim your, although I have to say, if you use it a lot overhead, which isn't really a recommended use, you might mess up your shoulder. I can attest to that one. It's also really handy for making chopped straw, which will come into the game when we talk about plasters. And the basics about straw construction. We want to make custom sizes wherever we need, but when possible, use the full bale. If we have to notch around structure or anything like that, it's easy to do. They're very simple to work with. We want to create a bale wall that is tight, keep it level, and keep it plumb vertically. We want the joints, if possible, to be staggered, and then we'll stabilize that with pins, which are either bamboo pins or wood dowels, and sometimes you can even stitch the bales together using the bale needle. You just sew them together and you sew them around your structural system. Once you've done that, if you have any loose gaps and any spaces between the bales, you just shove some loose straw in there. And that is your straw bale wall. So here we go with some straw bale construction techniques. They fall into two categories. The first one on the left is called structural straw, and the second one is infill straw. We'll start with structural straw. The straw bales are the structure. They are your wall surface, but they are also the structure holding up the loads. After we stack them in the configuration that we want, they're compressed before they take the load. So there's no settling unequally. They are pre-compressed, and then we put the load on top of them. This is a very simple and fast way to build, but it has some risks to it. It's also very cheap because you don't have any other structure system. It's also very good for beginners to do because you don't have to use wood tools and all that kind of stuff for most of it. You do for your roof. Here's earth bag and structural straw shed that I permitted, and it's in Broome County. It had a permit, and I wanted to permit a structural straw building in our area just to prove that you could do this and it could go through codes. So on the upper left, we see that it is sitting on a foundation of earth bags, which is again what it sounds. We like to keep our names simple in this industry. So earth bags are bags of earth stacked up, and that's our foundation. And we have pins there and a blue thing that's separating. That separation keeps the water from wicking up from the foundation into the bales, and that's pretty common with normal regular stud construction as well. There's always a barrier separating the foundation from the structure above. And again, we want that at least 12 inches above where our finished ground is. Once we get it stacked, we put a top plate on that and start tensioning it down. And in the middle, you'll see, in this case, what we used is turnbuckles that wrapped all the way around the bale wall, and we just tensioned those things down. We got about 1/2 inch to 1 inch per bale of compression. And once that was compressed, the wall was completely solid. It wasn't going anywhere. And then we built our roof on top of that and plastered it, and we had a nice, inexpensive shed building. A much more common way of building with bales that you'll see, especially in our area, is called infill construction. And that is where we fill in the space between the structure with the bales. There's a lot of different options of this, but this is the most common type of construction, and it's most common for a couple of reasons, mostly because if you're working with a builder, they're familiar with the construction system. It's the same one that you would use in other buildings. So it doesn't seem as weird, it doesn't seem as extreme as structural straw. You also get to build your straw walls under a roof. So in our climate, where you do get some rain, it's nice to be constructing with the bales, which you do want to keep dry, already when you have your roof finished. Here is a timber frame style of infill construction. This is one that we designed for the Albany area. And timber frame is a traditional technique of using larger pieces of wood joined together, and then they have large spaces, and those spaces are filled with the straw bale wall. You can set the bales on the inside or the outside of that structural system. So you can see, or even in the middle, you can see the structural frame exposed on the interior or the exterior. It's really your choice. And then the bales tuck around that structure and form a continuous plane of insulation, either on the inside or the outside. This is very similar to timber framing, except we're using just dimensional lumber, grouping it together as posts, and infilling the bales. And this is a great system to use because you don't have to use old growth trees or larger timbers. It's a little bit easier to get them. And when you're doing the design, you usually put the posts by where you have windows or openings and a few extra posts just to take the load, and then the straw bale gets slotted into that. Again, on the inside or the outside. This is actually the first straw bale building that I did in this area, and that was in 2002. We can even use it with regular conventional stick framing. Stick frame is the type of construction that you see most used in residential, where you have vertical stud elements, usually set at 16 inches on center, and that is your structural system holding up your wall. In the case when we're working with bales, we spread that out to 18 inches on center because our bales are 18 inches wide. We notch part of the bale out and slide it right into that. On the left-hand side, you see the interior of the wall. We have the structure on the outside. On the right-hand side, you see the exterior wall. The bales and the studs are meshed on the exterior. And then we have some cross bracing, which takes up lateral, which is loads pushing side to side on the building. In this case, you'll also note that the bales are set vertically, so they don't always have to be set down. In this case, they are vertical, and then we stitch them together around the studs. You can actually see the ties going across over the studs, holding that whole wall together as one unit. This is the Vines building, which I don't know how many of you know about the Vines building. We just completed it a little bit ago, earlier this year, and it is the first commercial straw bale building in the Northeast. So, and we used this system because it was very familiar to the builder, and adapting it to straw was very easy to do. And just because I like to be difficult and different, this is my own house, and I used a steel frame. I wanted to push what we could do, the detailing. This is as far as my research, this is the only structural straw, or a structural steel and straw combo in North America. I developed how to do this. The principles are similar to with post and beam or with wood frame. I'm just using steel. The reason why I chose steel is that it is the most recycled building material that there is. And when I purchased the frame, I purchased only recycled steel. At the end of its life, it can be recycled again. So the building that I built for myself is completely recyclable. Now, stuff happens in construction, and you'll notice that I do not have a roof. I have a roof structure, but I don't have a roof, and that wasn't supposed to be like that. When we were stacking bales, we wanted to have a roof so we could stack them safely underneath that while we were continuing construction. But because of the time frame for when we needed to get to our plaster work, we ran out of time, the roof was running late, we just had to start stacking straw. I had the largest collection of tarps in the Broome County area. But it proves that you can have things go wrong. You can have things go kind of sideways, and weird things can happen on the site, and you can survive it. I did have to replace, out of 1,000 bales, 2 bales that got wet. So we did pretty good. And I learned a lot about different ways of constructing. So I've done, I think, every type of straw bale construction that you can possibly imagine, and maybe some that people wouldn't like to try. And this is the small shed finished. When you're done stacking all the straw and your straw wall is ready, you put the natural plasters on. The plasters serve to keep the bale wall safe. So I like to use natural plasters, and natural plasters are primarily composed of clay, sand, lime, water, and some kind of fiber. Because we have a lot of straw, the fiber that we use is chopped straw. So those are the components for what is typically deemed as a natural plaster. You can use cement-based plasters or put a bit of cement into a natural plaster. I have done that. I prefer not to do that because I think it dries too fast. It's much more difficult to control what's happening, and it doesn't seem to play as nice with the straw bales. It has some different cracking and different properties. The natural plasters do seem to perform better over time with the bales. And if you want to have fun and you don't like just pure white walls, you can add different colors of pigment, and you can add mica particles and even marble. So you can play with the exterior a lot. The one thing that you cannot do is you cannot use synthetic plasters, and you cannot paint these walls with normal paints. If you want to color them, you can lime finish them, you can fresco them, and you can use wheat paste paint. But you cannot put paint on them because they can't be sealed. And we'll get to more about that. We're looking for at least 2 different coats. The first coat on the right is called the scratch coat. And I like, in our climate, all of this is really pertaining to the Northeast climate. I like to use a mix of sand, clay, a little bit of lime, water, and straw in that scratch coat. That scratch coat, we're aiming for 3/4 to 1.5 inches of material, and it's scratched so that it can grab the next finish that's going on. This is a preliminary finish that's covered directly on the bales. Our final coat, if you just have 2, is the finish coat. And again, in our area, I prefer to use a traditional lime and sand finish. And it's just lime and sand and water. And that is applied on, typically with a trowel. And this is vines. For vines, we did want a nice, smooth, clean, white appearance. So after this, we lime washed it with just a lime wash paint. Here are some of the tools that you use for plaster. You need some bins, and you need some things to stir things with. Normally for small batches and color and different things, you mix that by hand. You can also mix things with a mixer attached to a drill, but you don't ever want to put it in a concrete mixer because you will be very unhappy. It's very sticky stuff, and whoever you borrowed it from will be very sad when they get it back. But it doesn't really work so good because it's a much more sticky, gooey material than concrete is. The nice thing is, the people who have worked with it versus working with Portland cement-based is with Portland cement-based, you have to keep washing your tools and things dry very quickly. And the crew is saying that they loved working with natural plasters because they could just work all day. They didn't have to be too fast. They didn't have to worry about taking lunch off and it's already gone. They can't fix it. And they don't have to constantly wash their tools. So it's a much more adaptable and user-friendly way to go. I forgot to mention also the type of lime that we're using is not garden lime. It is a specific type of building lime called type S, structural hydrated lime, and that's what we want to mix it with. Yes, question?
Bottom left corner?
Yes.
Would you comment on that?
Yes, absolutely. So you can apply, spray apply with a gunite sprayer. And this works great for your scratch coat layer. And you just shoot that on and come back, knock it back, smooth it out a little bit, and scratch it, and you're good to go. So this was on my house. We spray applied because we were running short on time, and I had a lot of coverage with the walls. The one thing I did discover, this is another thing that kind of went a little wonky on us, was plaster weighs a lot. And so we were spraying one side of our wall, happily, and somebody noticed that wall was like starting to pull out of plumb, a little significantly out of plumb. We quickly braced that up and started plastering also from the other side. So the thing I learned, plaster both sides, because plaster is heavy and it will drag your bale wall down if you've got long spans of open bale. Typically though, plaster is applied with a hawk and trowel or by hand. You can spread it by hand because there's nothing, caustic or anything about that. So a hawk and trowel is typically how we put that on. There's also another technique which I would love to try, but it sounds very, very messy, called hurling, which they use a lot in England, where they actually throw it on with some kind of a palette, and it makes a really cool texture, but it sounds like a horrible mess. But I would like to try hurling at one point. I don't have any hurling tools, so we'll leave it at that. Some other tools that you need. So yeah, the trowels. This one, you need kind of different tools than you use for traditional, or not traditional, for cementitious materials. The trowels that we use for natural plasters are very soft. This one's actually plastic, and you can create your own with just a plastic yogurt lid. But very soft and very malleable. The material is very soft. It's very workable for a very long time. So you can spray it. You're going to need some spray bottles and some sponges to create different finishes with, but it's a very workable, forgiving material, very easy for beginners to learn, and a lot of fun to play with. Plaster, as I said before, is on the interior and the exterior of the bale wall. This protects the bales from the weather. It adds mass, it increases the thermal performance, and once covered with the plaster, the bales are protected and they do not deteriorate. So they're not going to have any problems, and no termites are going to get in that, and animals are not going to come in that. The other cool thing about it versus, say, vinyl siding is if you have the straw and the natural plaster, something happens and you do get water in your wall, the plaster will start to discolor. You'll know there's a problem right away. In your conventional frame wall, with the materials that we use today, you would never know. That vinyl is going to look pretty, your wall could be rotting behind, and you would never have a clue. So this really tells you what's happening in the wall if you do have a problem. It is a traditional and time-tested material. It's a material that's used all over the world and all through different eras of building. How time-tested and true? Well, archaeologists have found some lime existing on walls that are 9,000 years old. Is that long enough lasting for you? 9,000-year-old lime plaster. Also, it's fireproof. When there was a large fire in 1212 in London, after that had happened, the king decreed that all the buildings in the city must be lime plastered on the exterior for fire prevention purposes. It also allows for a lot of creative expression. It's very versatile. You can sculpt it, you can color it, you can put mica in, you can make it sparkle, you can create different textures and finishes. It's adaptable, it's durable, widely used, and very, very easily available. And I would say also user-friendly, hard to master, easy to try. Okay, so how did I get into this? How did I start? On the left, you'll see a straw bale building. This is the first one that I ever worked on, 2002. At the same time I was working on this conventional building, which any architect would be completely happy to have this as a commission, a beautiful, large luxury home. And they were both in design and planning and construction at the same time. When I went to meet with the owner for the straw bale, I was very curious because I had never, ever heard of straw bale building before. And I was the youngest person that he interviewed and the least experienced, but boy, did I want to try this. I was just like, what is this? I want to do this. This sounds exciting. And so I was selected, and I haven't looked back since. Actually, when we were in construction, he said, you know what? You're going to build one of these. I could not even fathom that that was even possible, that that would even I wasn't in the mindset of thinking that I would ever even build a house in the near future. It's like, yeah, whatever, yeah, right. But by the end of it, seeing the difference between conventional construction and the straw bale construction, the community, how the system worked, how easy it was, how adaptable it was, the properties it had, I was starting to really see a new way of building, especially in comparison to the conventional project, which I'm very proud of both of them. All the work that I'm showing is my work unless I'm noticing it. I have worked in both types. You know, I'm not just strictly a natural builder, even today. I wish I was, but even today. So then I went to study at a place called the Canelo Project, which is in Arizona, and it is run by Bill and Athena Steen, who, in my opinion, are probably the premier designers and builders and educators in the straw bale construction arena. They have written several books, which are great, and they have this wonderful school. I've taken workshops with them in straw bale construction, in plaster sculpting, also discussed clay floor, and different finishes, wheat pastes and colors and all kinds of different things. They are absolutely wonderful, and from being there and seeing this experience with them, I saw the beauty and the possibilities artistically of what this medium could do beyond the normal straight drywall walls and the conventional materials that we have been using here. There's so much more possibilities and dreaming is available. And they are craftsmen and artists, and they produce amazing work. The thing in the middle is actually, yes, it's actually a sink and a shower stall with natural clay plasters and lime plasters. There's a specific technique from Morocco called tadlik, and with using stones and olive oil soap, you can create water impervious finishes to even use in bathrooms. And they use a lot of color and just amazing, amazingly creative people. And this is Athena Steen with her shed of different types of clay with different colors and some of her artistic work. You can also put shells, tiles, bottles, all kinds of interesting things into your wall. Sky's the limit. But they are in Arizona, and the climate is not the same as all is here. So the next step I did was I met with a builder in the Syracuse area named Clark Sanders. And he makes wonderful buildings, and he taught me and mentored me in how to make straw bale buildings in our region and how to make it be efficient, beautiful, and long-lasting for the Northeast climate. And his work is also absolutely outstanding and beautiful. He's a very traditional builder. Hard to reach, though. He doesn't have a computer. I don't think he has a phone. And I won't tell you where he lives. So this is more of his work. So from those two experiences, I saw not only the artistic possibilities, but the performance possibilities of this material. Going through the process of making that first building, I was convinced, and within 5 years, I built my own building. So my client was right. On the left is a picture of his completed building, the first one that I did, and then the two pictures on the right are my built building. And this is another view of mine. I also have incorporated in passive solar. This is the south orientation. It's completely open. Because I have a lot of mass from the straw bale plaster walls and the concrete floor, I get a lot of passive solar and good performance with that. And this is another one. On the left-hand side of this slide is a straw bale building. And they don't always have to be finished just with plaster. There is plaster underneath there, but the owner wanted something different as well. So he recycled some slate chalkboards from schools, and so you can draw on the side of his house, and then up above that is some recycled wood. But there is plaster underneath those things protecting the bales, and then you can put whatever you want to on top of that. He needed to expand his house, so the next part, the addition that you see on the right-hand side of that, is actually made from shipping containers. And finally, the latest building that we completed was the Vines building, and this is in downtown Binghamton, and as I said before, the first commercial straw bale structure in the Northeast.
Where is that located?
This is at Fayette and Susquehanna, and you can go see it. Yeah, question?
Do your buildings have basements?
They can?
Could
Yep.
you repeat the question for the
Yes.
last one?
So there was a question about if the buildings can have basements. Yes, they can. Really, when we're talking about straw bale construction, the only difference is the exterior wall. Everything else can be the same. The basement, the floors, the roof, everything else can be the same. We're really just talking about that exterior wall surface. So let's get into the truth of what the straw bale walls are really. Most straw bale buildings have something called a truth window, and these show that yes, actually, the building is made of straw, and you can look at that. So we're going to talk a little bit about the differences between our conventional buildings and our straw bale buildings, with that in mind that really we're just talking about the wall surface, that exterior wall. So let's look at an architectural detail of conventional construction on the right and a straw bale wall on the left. Everyone who knows anything about straw knows that they have good insulation value. That's usually the first thing that people gravitate to, is the insulation. Our value is the resistance to heat transferring through the wall. It's what the building industry uses when they're explaining how much insulation value a wall has. So depending on when your house was constructed in this area, you have somewhere between R0, if you have no insulation, and maybe R21. Code is R21. So somewhere usually 16 to 21 is what is conventional. In a straw bale insulation situation, just the bales themselves have tested to somewhere between R40 and R50. So at worst, you're getting double or possibly even triple the insulation value. The walls are also breathable. On the right, you'll see a red line on that detail, right under where you see the zigzag, which is siding. That is a plastic membrane. We're creating buildings because we're trying to make more energy efficiency. We're creating buildings that are so tight, we've wrapped ourselves in a plastic membrane, a plastic bubble, to solve the problem of how to get more efficiency out of that wall system. Because we know it's important, let's do that. Bale walls do not have that. They cannot have that. They need to breathe. Sometimes moisture gets in, clay from the plaster pulls it out of the bale, and the wall can breathe. I like to say it's the difference between a rain slicker and a Gore-Tex coat. One of them breathes, and one is not very comfortable if you're wearing it for an extended period of time. And because of that, the wall for a straw bale wall is much more energy efficient. Once you add the plaster on top of that, it's even more efficient because the plaster helps give you that membrane. It increases the R value of the wall, although I don't have testing data for what that is. So the performance of the bale wall is significantly better and very different from what we expect in a modern building. Because we're so tightly wrapped, in current buildings, we need to add extra ventilation. Now we're spending fuel or electricity on venting our houses because they're so tight. And I think the wall should do that work for you. And in a bale wall, it does. And we're talking about the difference also between natural material, locally available, waste material, and even clay, which you can dig up on your property and it's free, versus materials that have embodied energy. What is embodied energy? Let's take a little detour into what embodied energy is. Are natural materials eco-friendly? Here we have two kitchens. I designed them both. They both have stone countertops. The one on the left is a slate countertop, which was mined near here and finished by a local family who makes them. What is embodied energy is the amount of energy required for that material to be mined, finished or manufactured, shipped to the site, and installed. And in the case on the right, this is granite, which is much more common and typical material that you see all the time. Yes, it's a stone, it's a natural material. But I don't know exactly where this one was, but typically they're mined in Brazil. They're shipped to Italy or Spain to be finished. They're shipped back to America, shipped to your job site, and installed. So all of that extra fuel cost is embodied energy. Yes, they're both stone. Yes, they're both natural. But the cost of energy is so much more for some materials, even the same product. So it pays to know where your materials are coming from. Shop local where possible. In construction, for straw bale buildings, the material is very low cost and sometimes even free if you can dig it up on your site. It's local, it's renewable. On the other side, you have the material cost in dollars as well as that carbon cost for the material. We have shipping and the embodied energy of the materials that are manufactured and brought to the site versus straw bale, which you can get from your local farmer, usually within 50 miles or less. On a job site, have you ever gone by a construction site and not seen a dumpster? Or two, or three? When I built my house, I didn't have a dumpster at all. No dumpster. There's no trash. Because the straw, if you have extra straw, you just toss it on your yard, or you chop it up and use it in your plaster. There is no trash from building these type of buildings. In the other components, yes, there is. And in the case of conventional building, we not only have the shipping, we have the packaging, and we have cutoffs and waste material from construction. And we do have a question here. Yes?
Would this be the same?
Hold on, Mark.
Good, you can give me a chance to have some water.
All right.
Would the straw be the same quality of straw that farmers use to feed their animals with?
So usually you don't feed animals straw because there is no nutritional value. Sometimes it's used as bedding or an agricultural material that you use for growing your lawn or something like that. But it's mostly just the waste product. All of the grains and stalks, or the grains are removed from the stalks. That's hay, the stuff that has the value, the nutritional value in it. The straw does not have any of those seeds. If you do get some bales with seeds, they're not so good for construction. You just want the stalks. So it literally is a waste product. Does that hopefully answer that? And when we take that straw out of the waste stream, we are sequestering carbon in that straw. It's a natural material that grows. Usually it takes 4 months to grow straw, so it's very renewable. And in growing, it sequesters carbon. When we put plaster on it, that natural plaster also pulls CO2 into itself for the remainder of the life. So we're on a benefit scale when regard to carbon. At the end of life, my bale building can degrade naturally. Pro tip, if you see mushrooms growing on your bale that accidentally got left out in the rain, don't use it in construction. But it just shows how quickly it can return back to nature. And then the clay plasters and lime, it's inert, so it just can go into the ground. And then we have the long lifespan. On the other hand, many of the building materials that we're using for conventional construction are not biodegradable. Many of them are made with petroleum products, such things as vinyl windows, vinyl siding, asphalt shingles, and when those things are disposed of, they release toxins. Also, our buildings right now are kind of like fast fashion. They're only made to last about 40 years, which seems shocking. And part of that is the structural system that we've developed with this plastic membrane because it causes the building to degrade faster. So that shorter lifespan of the building is causing a larger quantity of waste just because they don't last as long as conventional buildings. Now you say, I used to live in a building that was from 1840 in Owego. It's a wood structure. Yeah, that's traditional building. That does not have a vapor barrier. So once we've decided this plastic thing was a good way to go, we're causing all kinds of problems. When we're living in the space, here on the left you see my kitty sitting in a window. and on the right is a conventional building with that plastic membrane showing Tyvek. We are creating with our straw bale structures and the plaster actually a 2-hour fire rated construction. Now that means it's a rating system that codes use to see how long the building would not catch fire that people could egress safely from. And that doesn't mean that straw bale buildings will start to burn in 2 hours. They probably won't, but that's how long the testing lasts. I'm unfortunately going to tell you that the building that you're living in, if it's a conventional building, has 0 fire rating, no fire rating at all. Normal residential construction has no fire rating. And some of the building materials that we're using, like vinyl siding, if there's a fire and that vinyl siding is burning, it's emitting toxins that will kill you faster than anything else in that fire. And then we can't dispose of it. Because our buildings are also, the straw bale buildings are also breathable, the indoor air quality is far better than a conventional home. We're trapping not only the toxins that are in the materials that we're building with, such things as resins and VOCs from paints and adhesives, anything that you're using in that space, cleaning chemicals, food smells, anything, everything gets trapped in there. And now you need to add artificial ventilation to clean it out. Straw bale buildings don't need that. And those walls also regulate humidity. Clay tends to pull moisture into itself when it's very humid, and when it's dry, it releases it. So you don't need a dehumidifier or a humidifier. The building just does it on its own. And then a personal point, I prefer the organic feeling of those walls with a bit of irregularity and some character. I don't care what color you paint your drywall, it's still drywall. It's kind of soulless. And I really like the undulations you can get in a bale wall. Yes, you can make the bale walls very straight and simple if you like that, but you don't have to. Are there problems with this method of construction? Of course. There's no system of building that is perfect. There's no system of anything that is perfect. The thing that really is impacted a lot is the construction schedule, and that's because straw is available at a certain point in time. We want to start using it when it comes available, usually at the end of July, beginning of August, and then we want to build that up as quickly as we can. Usually takes 1 or 2 weeks to get the straw walls installed and start to plaster. And we need to start to plaster because plaster is a bit of a Goldilocks material when we're talking about natural plasters. It can't be too hot, can't be too cold, can't be too dry, can't be too wet. It likes it to be a nice climactic situation when it's being applied. And we need 60 days before a hard freeze. So you're kind of up to a wall in our area with getting that plaster done before it gets really cold. So that's one thing that's impacted that's a bit different. Another problem is that most of the straw bale buildings that you see built are built by homeowners because there are very few professional builders working on straw bale buildings. So it limits who can have one. If you don't have the ability or you don't want to build a building for yourself, you really can't hire somebody. So even if you desire to have a straw bale building, it's unlikely that you could find a builder who would be able to do that or would want to do that. There's also not very many educational materials available. There's not much testing on the system. There's a few things available. There's lots of good information if you search for it, but it's certainly not as ready available as for conventional types of construction. And the last thing is our walls are very thick. My walls are 24 inches. They're usually about 22 to 24. So that takes up a bit of square footage. So you're losing a bit of square footage. You have to pay a little bit extra to have that thickness of a wall. Those are the main downsides to it, really.
I have a question.
Yeah.
What happens when you nail
Hold on a
into
second, please.
One question here.
Here we go.
What happens when you nail into it, and do you have to nail into it to do things like install the windows, or even if you're going to hang pictures, or doesn't that create like kind of where water or maybe even insects or things can get in?
Yeah, it's not so much of a problem. Actually, plaster is quite strong. It can usually take about 60 pounds of weight. So if you're hanging a picture, you can usually just put nails right into that plaster. Now you're thinking if you have 3/4 inches and 1.5 inches, that's a pretty long nail to go through all the way to the straw. And even still, we have, you know, the truth windows, which are exposing the straw right there. You don't have to worry about things getting in. And then the nice thing about the clay plasters is they kind of do tend to heal themselves. The way that the clay plaster platelets work, when they suck up moisture, they move around a little bit and they self-seal, which is very handy. But that's an absolutely great question. When we do the windows, we usually like to put the structural members right where the windows are, and then we're nailing into those structural members, the timbers or wood framing or steel framing, and that's holding where our windows are. If you're building structural, you can still put windows in. You usually create a window buck, and you put wood dowels that tighten and hold that into the bale wall, and then you insert your window as normal. So let's go back to this question. This is actually a slide of my latest project in construction. It is the second heavy steel frame and straw building in our area. But why don't we build this way more? I mean, hopefully I've kind of sold you on the benefits of this, but there's a few reasons why I think we don't. And a lot of it is educational. We don't see many of them around. Has anybody ever seen a straw bale building in the audience here? A few people. Yeah, but not many. And most of the projects that I've designed that are residences are located on acreages. You can barely see them from the road. They're kind of hidden away and not very visible. Also, because they're self-built, you know, they're smaller. People don't tend to think of them as, oh, you could have a luxury home like this, or this is high-end construction or anything like that. And there's not many public buildings, places you could visit. And it's a bit different, so it takes time to adjust. But I think the real reason why we don't have more bale buildings is because of money. There is no big bale. There's no equivalent to the oil companies selling their Tyvek. There's no corporation of straw bale builders. There's no profit in the global market for this type of building. It's absolutely local. It is literally grassroots building. Yes, we have another question?
Yeah.
Hold on, Mark.
When I was over in England, depending on where you were in England, there's a lot of homes that have straw roofs.
Mm-hmm.
So do you do straw roofs too?
I have never done a straw roof. I would absolutely love to. I would love to do a straw roof. I think it's hard to find people who know how to do that. It's a very technical skill. And it's very expensive in our area because we don't have anybody who has that knowledge. This is where I think, you know, there is hope. And I have to give a shout out to the Vines project because they have done so much educational work through building their building, giving tours, having public workshops. Even Habitat for Humanity came on and learned how to build with this technology. It's starting, but we need to train people. Here now we have a professional crew who worked on Vines, professional, well-respected contractor, built the project, and he's actually continuing and building that next steel and straw building with us. So it's going to take time to get those professional builders, to get people trained in these skills that have been forgotten, plastering skills. And, you know, in the case of doing something like thatch roof, those are very specialized skills, and we don't have much of that in our area. But we're starting. We're starting. There is hope there. And even in the New York State codes, there is a provisional code for straw bale construction. So we're starting to break ground with this. And that's about all I have for you. So thank you so much for your interest in this topic. You are part of the change. And we do have questions. Yeah.
Hold on a second. I ran out of battery. Give me a second.
You want to shout it out and I'll repeat it?
Okay. Can I ask 3 questions at one time?
Yeah.
Okay. Is the plumbing and electrical systems in a straw-built house the same as a conventional house?
Okay, let me answer the first one. Are the plumbing and electrical systems the same as in a conventional house? Yes and no. Yes, except for one rule with the plumbing. You do not ever run water plumbing in a bale wall. You keep that all inside. No plumbing goes through bale walls. That's rule 1. Regarding the electric, if we use natural plasters, you just shove those wires in between the bales. You put them wherever you want. You need an outlet box, you take a stake, pound that box in, run it up there. Once we start using, this is another reason why I don't like to use cement plaster, because in the code, if you use cementitious-based plasters, you must put that wiring in cable, in sheathing. If you use natural plasters, it's not in the code. You just run those wires right there. So wiring is actually very easy. Plumbing, it's also very easy, and it's the same with the one rule, no plumbing in exterior walls where the bales are. If you want it there, you build a conventional wall just for that section. Great question. Okay, question number 2.
Question number 2. Let's say a person is building a conventional house and it costs $500,000. What would the same size house cost with the straw bale construction?
Okay, so another great question. The wall system is typically about 10% of the construction cost of the house. If you're doing the work, it's less. If a builder is doing it, it's usually slightly more because the plastering does take a long time. So, but it doesn't vary more than 10% from normal construction. The benefit that you get is the energy saving and cost saving. I forgot to mention this. In my own house, I have a ground source heat pump heating system. It's gone out a few times. They're a little flaky. I like it a lot. The first time it went out in winter, we did not notice our furnace wasn't working for 10 days because the house didn't cool off. The second time it broke big time during COVID, during shutdown. We could not get that system fixed for 10 months. 10 months through winter. We lived in our house. We have a backup fireplace, but we have a 4,000 square foot house. We lived just fine in this house with passive solar and a fireplace. How many houses could do that could perform that well just with the walls? So yes, it might cost more in construction. You're going to save so much more over the life of that. If we remember back to that chart, 15% is in the structure, 27% of carbon emissions, your fuel costs, are in the life of that building every year. Think about what you pay in gas or electric. It's going to be way reduced. So there's the benefit of doing it.
Okay, my
Third question.
Third
Yes.
and last question,
Give me-
I promise.
These are great questions.
Okay, so we have our straw bale house, and we go to Allstate and State Farm. What do they think of this?
They think it's great because it's rated 2-hour fire construction. And a normal house is not rated at all, anything. So your rates are actually less because it's classified as masonry construction because of the plaster coating. So they actually prefer it. And even codes, I've never had a problem with codes. Lots of people ask me, oh, doesn't codes give you a lot of trouble? Never had any problems with it. Our code guy absolutely loves it. He thinks it's wonderful. So it's surprising. Great questions. Thank you so much.
All right, we do have a couple of questions from the live stream chat. Although it seems like you answered one, how is wiring, plumbing, and water run? It seems like you answered that one. You talked about, you said ground source heating. Your heating system used is in buildings. Is it boilers, forced air? How could you describe your heating system or heating systems that are typically was seen in
Sure.
straw bale?
So if you're just looking at straw bale construction, you can use everything else can be the same. You can use any of the same type of heating systems that we're using now. If you're doing a straw bale house that's also more eco-friendly and more eco-oriented, you're going to want to look at an air-to-air source heat pump, a ground source heat pump, or alternative methods that are more eco-friendly, solar panels. I also forgot to mention the Vines building is not only the solar building, but it's also net zero energy. And by building with straw, you can get a more thermally protective environment, and you can more easily create a very energy efficient home. You can downsize the heating system, so that's going to cost less because the performance of it will be better.
It wasn't a question, but a comment. Ward from the chat says, I know a guy that built a hay bale house, and he made it like a Dr. Seuss house with an odd tower and funny rooms. The place was amazing. So I guess you can have a lot of fun.
You can, and if you're building it yourself, the creativity is, you know, unparalleled.
Any other questions here locally? Well, thank you so much, Laura. This was very, very enlightening and giving me some thought.
Do you want one now? Yes. All right. Thank you so much. I really appreciate you coming out.
Well, thanks again. Next week we have a local, I'm not sure how to describe her. It's a woman who was doing some research on plastics in the ocean and how plastics don't degrade. And she was actually doing some photography of it. And so she will be talking about her sort of micro photography of plastics that she found out in the ocean, and you know, and how much problem plastics are really causing. But the photographs that she takes are almost sort of otherworldly. So it'll be visually stunning, but also important to know what plastics are doing to our environment, and getting you to maybe rethink how we should be reusing plastics. So anyway, thanks again. As always, for those people that come, we would wish we had a better night sky for viewing, but we will certainly offer telescope tours for those that would, you know, haven't seen our scopes. We'll take you out there. So thanks again, and thanks for those watching on the live stream, and we'll see you next week.